Hello my dear students, welcome back to YouTube classes of Unique World Education UAE. So last class we discussed first 11 question from CBSE sample paper released in its official website. First 11 MCQ we completed. So let's continue with the same. So today we are discussing the 12th MCQ question from the same paper. Okay. So the question 12 is integral of dx divided by x cube into 1 plus x to the power 4 whole power 1 by 2. Alright. So if you want to integrate this thing, first we have to rearrange the same. Okay. So how I am rearranging this can be written as dx divided by x cube is already there. Alright. Okay. So from this term I am taking x to the power 4 whole power 1 by x power 4 whole power 1 by 2 I am taking common outside. Okay. So x to the power 4 whole power 1 by 2 if I am taking outside, in the first term the pending term will be 1 divided by x to the power 4 plus in the second term I am having common x power 4, I am having common 1 to the whole power 1 by 2, right? So x power 3 into x power 4 whole power 1 by 2 into 1 divided by x power 4 plus 1 whole power 1 by 2, right? So this will become what? Integral of dx divided by x power 3 into, this will become x power 4 whole power 1 by 2 means x square, this will become, this I can write x power 4 whole power 1 by 2 means it will become x square, right? So x square into 1 divided by x power 4 plus 1 whole power 1 by 2. All right. So this will become, we are having, this will become integral of dx divided by x cube divided by x square. I can write x to the power 5 into 1 divided by x power 4. If I want, I can write x to the power minus 4. So x to the power minus 4 plus 1 whole to the power 1 by 2, right? So now what I am doing here is this x power 5 is moving to numerator, so it will become x to the power minus 5 divided by, in denominator I am having x power minus 4 plus 1. Alright. So x to the power minus 4 plus 1 whole to the power 1 by 2 dx, right? Now you have to integrate this thing after rearranging properly. Now if you want to integrate this thing, you have to integrate by substitution. Integration you have to do by substitution. So how I am doing the substitution part is, here I am substituting x to the power minus 4 plus 1 I am substituting t. So x to the power minus 4 plus 1 is t. So that means minus 4 into x to the power minus 5 dx, that will be equal to dt, right? So from here I can easily write x to the power minus 5 dx will be equal to x to the power minus 5 times dx, that will be equal to minus 1 by 4 times dt, right? Minus 1 by 4 times dt. That means numerator of this integral of x to the power minus 5 dx, it will become minus 1 by 4 dt. So that minus 1 by 4 I am taking outside, so it will become minus 1 by 4 into integral of dt divided by x to the power minus 4 plus 1 whole power 1 by 2, that it will become t to the power 1 by 2. Alright. So now this t to the power 1 by 2 I am transposing into numerator, so it will become minus 1 by 4 into integral of t to the power minus 1 by 2 dt, right? T to the power minus 1 by 2, if I am integrating as per the formula, minus 1 by 4 into x power n will become x power n plus 1 divided by n plus 1. So this will become t to the power minus 1 by 2 will become t to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. So it will become t to the power minus 1 by 2 plus 1 is 1 by 2 divided by this will be also will become 1 by 2, right? Okay, so this 1 by 2 will move to, if I am moving into 2 by 1, so 2 multiplied with minus 1 by 4, it will become minus 2 by 4, that is minus 1 by 2. So minus 1 by 2 into t to the power 1 by 2. This you will get after integrating properly. Now we have to substitute that t back. So t is nothing but x to the power minus 4 plus 1. Okay, so this will become minus 1 by 2 into t is 1 plus x to the power minus 4. Okay, so 1 plus x to the power minus 4 whole power 1 by 2. Alright. So if I am checking the option, it is not there, so you have to simplify more. Okay, so 1 plus x to the power minus 4 whole power 1 by 2, you can written as minus 1 by 2 into root of root of 1 plus x to the power minus 4. Alright, okay. Now if I am simplifying further this thing, this will become minus 1 by 2 into take LCM of inside the root what we are having. Okay, so 1 plus x to the power minus 4, if I am taking LCM, it will become, or if you want to write 1 plus 1 divided by x power 4, right? Now just cross multiply this thing, so it will become minus 1 by 2 into root of x power 4. This I can write x power 4 plus 1 divided by x power 4, right? This x power 4 is coming outside the root, it will become x square, right? So this will become your final result is there here, minus 1 divided by 2 into x square into root of x power 4 plus 1, or you can write 1 plus x to the power 4 plus constant of integration. This is the final result after if you are doing the integration part very properly. So the answer of the question, integral of dx divided by x cube into 1 plus x power 4 whole power 1 by 2 is minus 1 by 2 x square into root of 1 plus x to the power 4 plus c. That is option A is the correct answer for this. Okay, so I hope this question is clear to everyone. So before doing integration, we have to rearrange the things very properly in order to do the integral part very easily. Okay. Alright, now let's go for the next question. Next question, if we are checking the next question, yes, this is also from integral by using the property of definite integral. Okay, so the question is very simple. We have to evaluate integral of 0 to 2 pi cosec to the power 7x dx. Alright, so how we are approaching this thing is we are using one property here. What property we are using here, you know, integral of 0 to 2 pi, integral of 0 to 2 pi f of x dx, that can be written as integral of 0 to 2 pi f of integral of 0 to 2a. Okay, integral of 0 to 2a f of x dx can be written as integral of 0 to 2a f of 2a minus x dx. This property we are using here. Okay, so if you are using this property here, if you are using this property, integral of 0 to 2a property, if I am using here, so this expression will change, right? This expression, how this will change? This expression integral 0 to 2a, yeah, integral of 0 to 2a f of x dx, that will be equal to integral of 0 to 2a f of 2a minus x dx. That property if I am applying in this question, this will change. Okay, so first let me write the given question as I equal to integral of 0 to 2 pi, integral of 0 to 2 pi cosec power 7x dx. Okay, so after applying this property, this function will change. Okay, this I am just putting equation number 1. Now after applying property, this will become I equal to integral of 0 to 2 pi cosec to the power 7x will become cosec to the power 7 2 pi minus x, right? This will become 2 pi minus x dx. Like this it will come. Okay, now we have to understand one thing. We have to understand one thing. Cosec of 2 pi minus x, cosec of 2 pi minus x, that will be equal to nothing but that will be equal to cosec of minus x. Okay, that will be equal to cosec of minus x, that will be equal to what? Minus cosec x. This also we know, basic property. So this question will, how it will change, you know, I equal to, this can be written as integral of 0 to 2 pi, integral of 0 to 2 pi cosec to the power 7 2 pi minus x, that will be nothing but as per this property of trigonometric functions, trigonometric ratio, this will be equal to minus cosec to the power 7x dx. This I can put equation number 2. Alright. Now if I am doing this thing, equation number 1 and equation 2, if I am adding, what you will get? I plus I. LHS part if I am adding I plus I to I, and RHS part if I am adding 0 to 2 pi cosec to the power 7x dx, if I am adding with 0 to 2 pi minus cosec to the power 7x, that will be equal to 0. So 2i will be equal to 0 means I will be also 0, 2i will be equal to 0, that is we got from here, right? That means I value will be also will be equal to 0. That means the value of integral of 0 to 2 pi cosec power 7x dx, that will be equal to 0. Basic property, that's it. Okay, so I hope this question is also clear to everyone. Let's go for the next question. Okay, yeah. Next question is, what is the general solution of the differential equation e to the power y dash equal to x? Okay, so e to the power y dash equal to x, it is given. We have to find the general solution of this. So this question I can return as e to the power y dash means, as we know, y dash means it is dy by dx, right? So e to the power, this can be written as e to the power dy by dx. E to the power dy by dx, that will be equal to x. Alright, that's no problem with that. Now I am going to take log on both sides. So if I am taking log here, log e to the power dy by dx, that will be equal to log x. Alright, log e to the power dy by dx, that will be equal to log x. So log e, it will become what? Here it will become log a to the power m equal to m into log a, that means dy by dx into log e, that will be equal to log x. There is no doubt in that. Log e will be equal to 1, so we are having dy by dx will be equal to log x. Okay, till now there is no problem, basic only. Now what we have to integrate. So before that we have to separate the variable. So this can be written as dy will be equal to dx transpose that side, so it will become log x multiplying with the dx. Now you have to integrate on both sides. Okay, so if you want to integrate log x integral, if you want to do, you have to integrate that by integration by parts. Okay, so you have to follow the elite order. So log x can be written as log x into 1. Alright, so integral of log x into 1 dx you have to do, then you have to integrate by parts. Okay, so integrate by parts, if I am applying here, it will become log x into integral of 1 dx minus integral of d by dx of log x into integral of 1 dx. Okay, this only we have to do for finding the integral of log x. Okay, so if I am simplifying this thing, so this will become log x into integral of 1 dx, that is x only, minus integral of d by dx of log x. Log x derivative is 1 by x, so 1 by x into integral of 1. So integral of 1 is nothing but that is x only, so x dx. That means we have to integrate log x into x minus integral of 1 dx. So 1 is nothing but that is x only after integrating. So this will become log x into x minus x. This is the integral of log x. So integral of, now if this question will rearrange into what? This question integral of dy, that will be y, that will be equal to integral of log x. I can written as integral of log x, I can written as log x into x minus x plus constant of integration. So log x into x or x log x. If you are observing the option log x into x minus x plus c, or you can take log x into x same as that of x log x. So x log x minus x plus c. Option B is the correct answer for this question. Okay, so I hope this question is also clear to everyone. Now let's go for the next question. So the next question is, yes, the next question, it's a bonus question, very easy question. We can, graph is given, we have to identify the graph is for which inverse trigonometric ratio. Okay, so if I am observing this graph very carefully, you can easily understand minus 1 to 1 is the domain of this function, and what about the range? Range of this function is 0 to pi. Okay, so minus 1 to 1 is domain and 0 to pi is a range, and at pi by 2 the value will become equal to 0. Okay, at pi by 2 the value equal to 0. So there is no need of explanation for this. Minus 1 to 1 domain, 0 to pi range, and at pi by 2 the value of the function is attaining 0 is nothing but the function is nothing, it's cos inverse x. Okay, it's a very easy question, bonus type question. You can easily understand by observing the graph very carefully. Okay, all right, now let's discuss the next question. So the next question we are having the function f from R to Z, real number to integer, the function is defined by f of x equal to GIF, greatest integer function. Okay, so we are having 4 options. The function is continuous at x equal to 2.5 but not differentiable at x equal to 2.5, like some options are given. So you have to understand one thing, f of x equal to greatest integer function, f of x equal to greatest integer function GIF. So GIF, you have to understand this function is discontinuous. I hope many of you know the idea. The function is discontinuous at x is an integer. When x is an integer, the function is discontinuous. Okay, the function is discontinuous at when the value of x equal to integer. Okay, and this function is both continuous. The function is both continuous and differentiable. The function is both continuous and differentiable when x not belongs to z. If x is a number other than integer, the function is both continuous and differentiable. So everything in this question is depending upon the value of 2.5. As we know, 2.5 is not an integer. So if I am observing the question continuous at x equal to 2.5 and differentiable at x equal to 2.5, no. Okay, why? Because the function is what? The function is continuous and differentiable only when x is not an integer. Okay, x is not an integer. Okay, so the best and suitable option is the function f of x is continuous as well as differentiable at x equal to 2.5. If you know this result, the function is both continuous and differentiable when x is not belongs to integer. The correct option for this question is option D is the correct answer. Okay, so now let's go for the next question. So a student observe an open air honeybee nest on the branch of a tree whose plane figure is a parabolic shape given by x square equal to 4y. Then the area of the region bounded by the parabola x square equal to 4y and the line y equal to 4. Okay, so this question is from AOI, application of integral. So we have to understand the thing. Okay, so first you have to plot the graph of this parabola and the line. Okay, so parabola is given as x square equal to 4y. It is an upward parabola along with the y-axis. Okay, that we know. So this parabola will look like this. Okay, x square equal to 4y. So this is the parabola, x square equal to 4y, and we are having the line y equal to 4. Okay, suppose y equal to 4, it is a straight line which is parallel to x-axis. So y equal to 4. All right. Okay, so first and foremost important thing is we have to find the point of intersection of this. Okay, suppose there is line and the point is intersecting at the two places, so we have to understand, we have to find the point of intersection. Okay, so x square equal to 4y, y equal to 4. This y equal to 4, if I am substituting in this equation, x square will become equal to 4 into y is what we are having, 4 into 4. So x square will be equal to 16. So x square equal to 16, we will have the values x is equal to plus or minus 4. So this is lying on the first quadrant, so this will be 4, x is 4, y obviously it is 4 only, and here we are having x will be minus 4, so minus 4 comma 4. All right, now we have to find the area of this region. So area, basically we have to find the area of the region bounded by the parabola and line. That means complete area we want to find. So this area we have to find, along with that you have to find this area also. Okay, so as we know, if I am observing this thing very clearly, you can understand this is symmetric region, right? Both the region are symmetric to each other. So any one of the area you have to find, then that area you have to multiply by 2, you will get the entire area. So area, here I am going to calculate area with respect to y-axis. Okay, I am going to calculate by considering a vertical strip. Along with the y-axis, I am calculating the area with respect to y-axis. So area with respect to y-axis, that we know, integral of a to b with respect to y-axis means, as we know, that will be equal to x dy, right? Area with respect to y-axis means that will be equal to x dy. So from here I can write x x square, the curve under parabola, right? Sorry, the area under this parabola only we have to take. So x square is equal to 4y, as we know, x square equal to 4y. That means x will be equal to root of 4y. So root of 4y means root of 4 means 2. So this will become nothing but 2 root y. Okay. So 2 root y means this can be written as 2 into y to the power 1 by 2. There is no doubt in that. So required area will be equal to, as I told, we are calculating the area of the one region, and this area you have to multiply with 2, you will get the entire area, right? So required area will be equal to 2 into integral of from where to where this limit is changing from 0 to this will become 0 4, right? Definitely this will become 0 4. So integral of 0 to 4 x dy. So x is 2 y to the power 1 by 2. So 2 y to the power 1 by 2 dy. This only we want to integrate. So area will be equal to 2 2s are 4. This 2 also I am taking outside. Then y to the power 1 by 2. If I am integrating, it will become y to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. That means y to the power 3 by 2 divided by what we are having, 3 by 2. Okay. So this you have to integrate. This thing from 0 to 4, right? This 3 by 2 it will move to numerator, so this will become, area will be equal to 4 into 2, 8 by 3 will come. So 8 by 3 into y to the power 3 by 2 from we are having from 0 to 4. Okay, only upper limit only we have to substitute because lower limit is 0. That means 8 by 3 multiplying with y to the power 3 by 2, that is 4 to the power 3 by 2. Alright, so 4 to the power 3 by 2, what we are having, 4 to the power 3 by 2 means that will be equal to 2 square whole to the power 3 by 2, right? So this cancel, they are basically equal to 8. Okay, so 4 to the power 3 by 2 means 8. So your answer is nothing but 8 by 3. You have to multiply with 8. That will be equal to 64 divided by 3. If I am checking the option B is the correct answer for this. It's a very easy question if you know the basics of application of integral part. Okay, so 8 by 3, if you want, I think that part is missed for this when I am writing. So if you want, I will write here 8 by 3. You have to multiply with the 4 to the power 3 by 2, that is 8 only. So 8 into 8 by 3, you will get 64 by 3. Alright, so 64 by 3 is the correct answer for this question. I hope this question is also clear to everyone. Let's go for the next question. Okay. So the next question is what we are having. The next question, let's check. Okay, yeah, this 19th and 18th question, 19th and 20th question is from basically from assertion and reason topic. So there are 4 options given. Option A, both A and R are true and R is the correct explanation of A. Both A and R are true but R is not the correct explanation of A. C is A is true but R is false, and option D is A is false but R is true. Okay, so let's discuss the 19th question. Consider a function f of x equal to mod x plus mod x minus 1, x belongs to R, then f of x is not differentiable at x equal to 0 and x equal to 1. So as we know, modulus function is always continuous, right? Modulus function is always continuous because we know the graph of this modulus function and the proof also we studied. Okay, so for solving MCQ, that much understanding is not at all required. So just understand modulus function is always continuous. And what about the differentiability of this function? Suppose we are having the function f of x equal to mod x plus mod x minus 1, right? Mod x plus mod x minus 1. This function is not differentiable when value of x equal to what? These two terms what we are having inside the mod, this will become 0. That function is not differentiable, right? So x is equal to, first term we are having modulus of x, so it is not differentiable at x equal to 0. And what about the second one? It is not differentiable at x minus 1 equal to 0. So x minus 1 equal to 0 means x is equal to 1. So we can say at x equal to 0 and x is equal to 1, the function is not differentiable. Yes, that's the correct thing. It is given as the assertion. So the function f of x equal to modulus of x plus modulus of x minus 1 is not differentiable at x is equal to 0 and x equal to 1. That's the statement is perfectly fine. Okay, now the second one is Now the second one is the function f is from r minus 2n plus 1 pi by 2. Sorry, this is 20th question. Okay, suppose f is a function is continuous on the interval a to b and c belongs to a to b, then f of x is not differentiable at x equal to c if limit h tends to 0 minus f of c plus h minus f of c divided by h not equal to limit h tends to 0 plus f of c plus h minus f of c divided by h. That means the reason what it is given, f of x at x equal to c, the function is not differentiable means it is given that limit h tends to 0 minus f of c plus h minus f of c divided by h. That means it is left hand derivative. Yes, the function is differentiable only when left hand derivative and right hand derivatives are equal. This is nothing but left hand derivative as per first principle of derivative, right? So this is your right hand derivative. So the function is differentiable only when LHD and RHD are equal. But in this case it is given what? F of x is not differentiable at x equal to c when they are not equal. So the statement is also, it's like converse statement. Okay, so the reason statement is also perfectly correct. So the correct option what we can select from here, both a and r are true and r is the correct explanation of a. So you can select the option a as the correct answer for this question. Okay, all right, now let's discuss the next question from assertion and reason. The function f from r minus 2n plus 1 pi by 2 n belongs to z to minus infinity to minus 1 union 1 to infinity defined by f of x equal to sec x is not 1 in its domain. Okay, so the explanation, sorry, the assertion is perfectly fine. Why it is perfectly fine? As you know, no trigonometric function. Question number 20 explanation I am doing here. Question number 19 here. Question number 20 is here. Okay. No trigonometric function is 1 in its domain. Every trigonometric function are on 2. Okay. Every trigonometric function are on 2 functions. So this is what it is given. It is not 1 in its domain. It is perfectly fine statement. Okay, no trigonometric function is 1 in its domain. All trigonometric function are periodic. Okay, now the next statement is the reason the line y equal to 2 meets the graph of the function at more than 1 point. Definitely it is fine. Okay, so I am just drawing the rough figure of sec x function. So as you know, sec x function will be like, how the graph of sec x function will come. The sec x function graph will come like this. Okay, the sec x function graph, I am just marking value, so this will become 0. Here I am having pi by 2. Then odd multiples will come. So odd multiple means here 3 pi by 2 and here 5 pi by 2, etc. It is coming. Okay, so this value will be this value we know that will be equal to 1. So here also this odd multiple will continue. So it is given that the line y equal to 2 meets the graph of the function at more than 1 point. Suppose here y equal to some 2 is there. So if I am drawing this, yes, obviously we can say that the y equal to 2, it is touching the graph of the function at many points. Okay, so the reason is also correct. It is not 1 function. Assertion is also correct. So the question number 20 also, this question number 20 also we can consider option A as the answer. Both assertion and reason is correct. Okay, both assertion and reason is correct, and assertion is the reason is the correct explanation of assertion. Okay, no need to think anything, only we know every trigonometric function is periodic. It is not 1 function in its domain. And if I am drawing the graph roughly, we can say that y equal to 2 is a line. It is stretching the given function f of x equal to sec x at multiple points. Okay, so that's all about. We completed all the 20 questions from this part. So I hope each and every question is clear to everyone. So next class, next topic, we will consider the second session, MCQ session we completed in this session. Okay, so thank you for once again, thank you for watching YouTube classes of Unique World Education. Okay, bye everyone.